morning, fourth grade. So this week we have been creating different experiments with things that we have at home. Yesterday we were able to see how we were able to make different layers of water based on how heavy we were. We were able to make different layers of water that we dyed using food coloring, and depending on how heavy they were, some sank to the bottom if they were more heavy, and then some floated to the top. Now, while I was prepping that experiment, one of the things that I had was hot water when I was mixing it. So I want to do an experiment on where we compare how quickly the food coloring dissolves in different temperature water. For today's experiment, you will need food coloring, the ever color of your choice, 3 glasses of water, 1 ice cold, I have 3 ice cubes in there, 1 regular room temperature, I got this from the sink, no ice, and then also 1 cup of water that is hot. I boiled some water, and I don't know if you guys can see, but there's steam coming out of this cup of water. So what I am gonna do now is I'm gonna put about 2 drops of green food coloring into each of these cups. Now before I do that, I want you to make a prediction on Nearpod. So on Nearpod, I want you to write 1 sentence. What do you think is going to happen to the water once I add food coloring? Are they all going to be the same? Is the room temperature going to be different from hot? Share your thinking on Nearpod now. My prediction is that the food coloring that we place in the hot water will diffuse a lot quicker. Okay, so we have our 3 glasses of water. This one is ice cold. This one is room temperature, and this one is hot. I'm gonna put 2 drops of green food coloring in each cup. And I want you to pay close attention. On your next slide, you will share your observations. So please pay close attention to what happens to our food coloring in each cup. I'm gonna start out with the cold one. Put 2 drops. 1, 2. I'm going to put some in the room temperature one. 1, 2. And some in the hot one. 1 and 2. I noticed that once I dropped the water in, it both went to the bottom. The room temperature one moved much more quickly than this ice cold one, and this hot one, it looks like it's almost done dissolving into it, if not all the way done. See how our hot water is completely green, not as splotchy as this ice cold water? So keep observing what happens to our cups. So we're gonna let it sit, and I want you to go on Nearpod now and record what happened to our hot cup of water, our room temperature water, and then also our ice cold water. Our hot one is completely done dissolving. Our ice cold, it's still splotchy and it's still not completely dissolved in, but our room temperature one seems like it's almost done. So go ahead and record your observations on Nearpod. All right, thank you for sharing your thinking. It has been about 1.5 minutes since I dropped in the food coloring into each cup. The hot cup, it is completely dissolved. We see that it is completely mixed in with the water. Our room temperature one is after our hot one dissolved like immediately, like I want to say like maybe 10 seconds after it was dropped in. Our room temperature one took about a minute, but it dissolved in the water. Now our ice water, it is still mixing in. I wonder why. I'm gonna let it finish up. By the way, I have not mixed this with anything, so we're just letting it dissolve by itself. Alright, it has been about total of 4 minutes, and it now looks like our ice cold water, our food coloring in our ice cold water is about done dissolving into it. I noticed the way the food coloring dissolved was depending on the temperature of the water. Our glasses all had the same amount of water. The only difference was the temperature. We had boiling hot water, room temperature water, and ice cold water. Now, water is made up of small molecules. These molecules, even though we can't see them with our bare eyes, they are always moving. And these molecules are what make up the water. However, the hotter that these molecules are that we can't see, they move faster because they have more energy. And when they are colder, they move very slow because they don't have enough energy. So in this experiment, the molecules that were in this hot water, they were moving very fast, and it helped the food coloring mix very quickly. And it helped the food coloring mix very quickly because of how much energy was in this hot water, because the molecules are moving fast, and the fast molecules help the food coloring move around. You saw how the food coloring immediately moved to the bottom and then dispersed out. Those molecules that are moving fast cause the food coloring to spread quickly and make our cup green. And the same thing for our room temperature water. Our room temperature water, the molecules are not moving as fast. They're moving fast, but just at like a regular pace. And that's why it took the food coloring a bit longer than the hot water to mix, because they don't have that much energy, so the molecules are moving the food coloring a bit slower. Now in our ice cold water, the molecules are moving really slow. They don't have that much energy, so they are moving really slow. And since they are moving really slow, it moves the food dye that we put in there, it moves it much slower. And that's why it took much longer for our ice cold water, for the green food coloring in our ice cold water to disperse within our cup. Now about 6 minutes later, we see that the food coloring is completely dissolved in. If you guys, see if I can turn it. I don't know if you guys can see kind of those, if you guys can kind of still see those streaks that are inside the ice cold water, it's because it's still not done mixing. Like in our hot and room temperature, it is completely dissolved. But there are still some streaks that are moving to mix in with our ice water. In this experiment, we were able to see that water is made up of different molecules, and these molecules move at a different speed depending on their temperature. Hot molecules move really fast. Room temperature, like regular water, move kind of slow, like regular. And then ice cold water molecules move really, really slow. Remember to click submit on your Nearpod, and I will see you guys soon. Have a great Thursday. Bye.